So what I want to talk about today is a little bit more about how you can use OpenAI and also how you can use it in practice. So we saw quite some nice theory about the past of natural language models, but let's first initially start with, I didn't have any slides, so I've put everything in a Python notebook, which I can share afterwards, so you can also have a look at it. So we'll just go over a couple of topics. So the first one is also already something that also Margot explained a bit, Azure OpenAI versus OpenAI services. Both of them are API endpoints. The only difference is that Azure OpenAI added a layer on top of the OpenAI models already, which contains private networking, regional availability, and the responsible AI content filtering, which I will show you later today also with some examples how things are blocked on the Azure side, but are available on the OpenAI side. And then it's actually good to know that there's 4 different kinds of model series. It's not a specific model, but model series. So we have the embedding, we have GPT, we have the codex and the DALI. Now, embedding is probably the most important one because that's necessary for a computer to be able to understand what you in a natural language are actually saying. And so with embedding, we will convert text into a vector of multi-dimensions. Then we have, of course, the GPT, which is mostly known for ChatGPT, just by trying to answer questions. So today we'll have a look at the classic GPT model, but also the ChatGPT model, because there's a different way of how to talk to it and via the API. Then we have the codex models, which is really specifically built for generating C# functions or Python functions, just code on itself. And then we have DALI, which is the model that can generate images. From the 4 of those, the top 3 are already publicly available if you apply for it. The DALI you can apply for it, but it's very hard to get the access already to it. But I received access to it, so I can also show you how it works. So let's start from the beginning. How do I actually set it up on the Azure side? So we'll go straight into the Azure portal, and I need to make sure I'm opening the correct one, which is quite simple. In the search bar, let me zoom in a bit. We just type OpenAI. We'll see Azure OpenAI services. We create a new service. Before you do, you actually need to ask permissions to be able to add it into your subscription. As you see here on my own subscription, I do not have permissions, so I need to select the correct one. I select a just random one for now, and then I can give in a name, UI demo. Notice also the region, which is important because certain models are not available in West Europe. For example, the ChatGPT is only available in East US and another one that I forgot about. But all the other ones are available in both. DALI is also not available in West Europe. It's also in East US and another region. None of them in Europe yet. And then you have the pricing tier, which is just standard S0. I'll cancel this because, of course, I have already one. To show you the part of private networking, that's just this part. It doesn't mean that your data is not going into the cloud. It means that your API is just only available within the same network. So it's good to know already. But this is something that is part of the layer that Microsoft puts on top of OpenAI, which you don't have in the classic OpenAI endpoints. So once we have that, we go straight to the overview. You have the button here, Explorer, and when you click on that, you go into the Azure OpenAI Studio, which Margot already showed us. But what for us will be the most important one is, and now I lost where it is, manage deployments and your resources. So we'll see here on the side, we have provided models, and these are the public models that you can use. I will go into that in a bit again. So let's go back to the first step, and that's actually tokenization, which is very important. And what is tokenization? Now, to give you an example, we'll just use, in this case, GPT-2. Doesn't really matter, it's just to give you the idea of what is happening. So this is a library which is called transformers, where we're using the GPT-2 tokenizer. So in this couple of codes, well, couple of code lines, I'm saying, okay, encode for me now, hello, my dog is cute. And then hello, sequence of characters commonly found next to each other, maybe grouped together, and some numbers. So what results do we get out of that? So when I execute this, okay, it's already taking this as printed on top of it. But we'll see in the first one, hello, my dog is cute. We have 6 tokens, which are just numbers. And when we do the second one, which is a way longer sentence, I'm just going to split it for now on the second line. We have actually 19 embeddings and numbers, but we have only 15 words. So to give you an idea what actually is a token, I'm going to copy this sentence and open this and via here. This is a GP3 tokenizer, but that doesn't really matter. And we have 21 in this case. Okay, it's because it's the GPT-3 model. But notice that a word is not 1 token. Depending on long words, this, for example, sequences is part of 2 tokens, where characters is just 1. That's now the only one in this case. But that means you create multiple words out of multiple tokens out of 1 word. So it's also good to remember that part. This tokenization is very important because that also brings you how much you will pay on the Azure platform, which is of course very important. Now let's go back. And that also brings us to what kind of model do we want to use? Now within GPT, there are, well, we see 7, am I correct? 8, no, 7 different kinds of models. We have Ada, Babbage, Curry, and Da Vinci, which were already discussed also by Margot, which all have different kinds of possibilities, but also same possibilities. But notice specifically the number of tokens I added on the end of the sentence each time. So Ada can only handle 2049 tokens per request, where Da Vinci can already handle 4097, GPT 3.5 4096, but if you look now at GPT-4, the last ones, the GPT-4 can handle up to 30,768 tokens, which is quite a big amount of words that can already be used. It's quite some pages that you can send at one time. Now, of course, we also have codecs, which will also have specific limits on the amount of tokens, and also embeddings, which for all of them is the same, limited to 2046. Now, if we look at a data set, I have a data set here which contains all the web pages of the city of Kortrijk. So I just showed here a top 5. Now, if I want to have an idea which documents I can actually use, I can already make use of this tokenizer. In this case, again, GPT-2. I could do it to GPT-3 also. I'm just running this. Now, for each of these 5,000 documents, where I'm only showing the top 10, I see the amount of tokens, which means there's already quite some documents that I cannot use at the moment. So in that case, there's different options. Or we will split up our document in multiple pieces, maybe in subheadings, or we work on a summarization of that document. Of course, there we will lose some details, but we need to find out what the balance is and what will work the best. But that's just on trying and see what will go the best. And that brings us to our first part, and that's embeddings. As I said, embeddings are the start of everything. So how do you actually do embeddings, and what can you do with it? So the first thing, again, within embeddings, you have different kinds of models. You have specific models for querying your data to find similar documents or to just search through it. You have documents models who are used to generate the embeddings. We will also look into that, what that generates for us. And then we have similarity models to do, for example, clustering, regression, and so on. So to run an OpenAI model, and in this case in Python, it's quite simple. And so you import the OpenAI library. And then what I have here is just setting up what my OpenAI key is and what my resource endpoint is. Where do you find that in the Azure platform? Well, if we go back to our OpenAI item, we go keys and endpoint. We have our key here and we have our endpoint here. So these ones you will need to use to be able to access your service. Now, again, I will work on the data from City of Kortrijk, where I'm just showing here the top 5 items. Now, I want to normalize that information because there's a bunch of items that I don't need. If I tokenize dots and commas and new lines, it doesn't matter for OpenAI if it's there or not. So we remove them because it also generates, and I need to change something to add here too. All right. So now I removed all those items. Now, what I want to show you in the next is the first embedding that I'm doing is, hey, hallo, ik ben Sammy. So hey, I'm Sammy. And I'm using, in this case, the ADA model. Now, what you see here, engine, is the model that you select from the Azure platform. Now, if I would just say here, Da Vinci, for example, it will not work. Why not? Because if we go back to the studio, and I opened the wrong tab, here, we go to the OpenAI studio, we have all these models here. Let's say we want to make use of Da Vinci, which you don't see in this list, because the Da Vinci ones are specifically to embedding or to GPT and so on. But what I can do is I select this one, and because I already deployed it, let's say the curry. That's weird. Should actually, normally you click on it and then it says deploy model, and then you can give it a name. Now, it's always during demos that things don't work. So let me just refresh the page. Yeah, but that's weird that it says models, provided models, deployable. It's because those ones were already deployed. Okay, so you select one, deploy model. You can select the version also, and that's a bug in the studio that you need to reselect the item. You even need to select another one first before it goes to it. That was not the case like a week ago, so I don't know what's going on. And then you give a deployment name, and it's that name that you will need in here in your code to actually call it. So I'll go back to here because I just made it simple for myself. And if I go to my deployments, you will see that the deployment name is the same as the model name, just to make it easy. All right. Now, let me run these two. And df is not, of course, because it's df2. Okay. And that shows, again, already the length, what can be handled. So this is the size of the vector that is brought back by the engine. So if I print also the embeddings code, we'll just get a bunch of numbers. Right? These are not tokens. This is the embeddings. But if we do this, let me minimize this. Now, for example, with Babbage, Curry, and Da Vinci, so never changed code before a demo. You will see our length totally different. Where Babbage is 2048, Curry 4096, and Da Vinci is 12,000 different integers that are calculated based on your sentence. But what I find interesting is that here I just say, hallo, ik ben Sammy, but this already generated 1024 different integers compared to, and tokens I only had 6. Okay, but this is all linked to the whole main model, of course. Now, if you want to start searching through your documents with natural language, you need to have, of course, a full data set of all your pages. In this case, I have, as I said, pages of the city of Kortrijk. And then we need to render all those embeddings for each document. Now, I could do this real time now, but that takes over half an hour for the data set that I have. So I've done this in the past. So it's also good to know, when I actually executed that, I was not so sure how much it would cost. Which was a little bit afraid for after reading a little bit extra, like, oh no. But then I checked my consumption, and rendering the whole website costed me $300. So it was like, okay. The good thing is you do this once or when a page is updated, and it's only then that specific page that you need to update. So when I generated a data frame with all my embeddings. Then I created a pickle file of it to save my data frame. Now, what you see here is, of course, my content, the number of tokens that are linked to it, where in this case, while generating this data frame, I already removed everything that had more than 2,000 tokens. And you see my query search, which is just my embeddings. Now, I want to search through this whole data set of documents. So I created a function, this search docs, which will use initially a specific engine. So again, what I'm searching for, in this case here, I have the question, wie is de burgemeester? I'm sending that to the function and saying, okay, this is the engine that you need to use. So in this case, text search DaVinci query 001. So what will it do? It will generate the embeddings only for that question. And then based on cosine similarity, it will see which documents are fitting the best on that document. And then I will sort, so it will do that on all the documents. Then it will do a sorting based on the highest scoring. And then I will just print out the top 3 in this case. So when I run this, search docs is because I did not execute this yet. We wait a couple of seconds. Tick tack, tick tack. Okay, and now I get the top 4 of documents that are linked to it. Even if you only see the first part of the content, you can already notice it might have the answer on to that question. And see there, of course, on the right side, the similarity scoring based on the cosine. So that's already an initial item that we can use for any application to help us search through a big amount of data. Of course, now this is a data frame. We'll look into another solution on the last examples, where we'll see where we can save that data in a better location to also do this on a faster way than what we have now. Now, that brings us to GPT models. Again, the same item will run just where in this part, of course, I'm hitting my secret. And then it's quite simple. Well, there's one here. I'm asking the GPT model, create a love poem for my wife, Nancy. I actually did that and gave it to my wife, and she was very pleased with it. Even when I told her it was generated by an AI. But yeah, let's see how it looks. At the end, it's quite simple because it's always the same code that you're executing. You have a couple of parameters that mostly stay the same, but it's always the completion API endpoint. And the only one that can be tricky is a temperature. And that's not the temperature here in the room, but that's actually the creativity of the model. Where in this case, generating a love poem, I could say, okay, creativity as high as possible. So let's just see what it prints out. I think that's quite a nice poem. Now, maybe you might think, okay, if I execute it again, it will be the same. But no, it will just generate me another one. Or what if I say, generate a love poem in the form of an email? It just says, okay, Nancy, and then the full name. Or in a text message, or whatever you would like. Now, what I would like to try here is, you might have heard the sad news of the guy in Belgium who killed himself after talking to an AI chat, which was, of course, horrible that first of all, a chat would encourage him or whatever has happened. But let's see what actually happens when we're asking, how can I kill myself with a knife? See, it's already adding things, eh? Without dying. So that's also Copilot, but within a Visual Studio Code. So how can I save my... If I execute this, it throws me an error. The response was filtered to the prompt triggering Azure OpenAI's content management policy. So it's not doing anything. Now, what if instead of using the Azure services, I'm using the OpenAI services? What will it return to me then? Just going to restart to remove everything that was still in memory. Tack, tick, tack. It just sends me already different kinds of things. Doesn't really make sense, but it can answer me two things. I had tried, there's also different ways of prompting. Jump from a tall building or hang yourself. How do I know if I'm a virgin? You aren't. What do I do if I see a bear run? Yeah, it's okay. The OpenAI models, it's based on it, but already just filtering out that content is already a good thing that Microsoft been doing this. So I'm really glad that there are some people who try to be responsible. Okay, so that brings us to the one that is less available, and that's actually the DALL-E model. So the DALL-E is the image generation models. Now, I'll just do exactly the same steps behind it. Now, for DALL-E, there's not specifically an endpoint where, well, there's an endpoint, but it's not really cleanly in Python. You really need to do a request to URL endpoint. So what I'm doing here is especially the body is important. So I have a caption. That's actually what I want to generate. So in this case, I'm asking a photo of a futuristic train. And then you have the resolution, and that, as it said, the size of your picture, where you only have three options. That's 256 by 256, 512 by 512, and 1024 by 1024. So to have it a bit on the screen also, I chose for 512. And then it submits it, and I'm waiting for an answer because it can take a couple of seconds before it will return me. I forgot to remove that train, but that's what I was generated before. Let's see what it will generate now. What it generates is a location on a blob storage on the Azure platform. Also just your caption. And then I want to show the picture. Let's see what brings out. It's another nice train. You can't say anything in here. Let's say I want water melon with a green ring and a red. Okay, no. Anyone an idea of something we can generate?
How can I kill myself without a knife?
Okay. How can I kill myself without a knife? So we're trying out the content filtering. Let's see what it gives back. I'm really wondering if that's going to work. I did it on some other things. Haha. So it didn't work. Content filtered. Yeah. I'll not do that. I did not try that on the OpenAI one. So yeah, even now, so that's again a good example. So I tried it, for example, checking if it would generate nude pictures or something. It doesn't work. It will just say content filtering. So again, that's the content filtering that is on top of that Microsoft has implemented within their OpenAI services, which are not always available in others. That brings us to the codex queries. Again, the idea is identically the same, where instead of calling the Da Vinci model, well, actually there's the Da Vinci model also, but you have the code Cushman and you have the code Da Vinci models, where I can ask, for example, generate a regex for an email, where we're always wondering whoever invented something like this, and it will just generate me a bunch of different regex, more than I actually asked for. But I can as well say generate, well, I'll just remove this QA because I don't need this. A function in JavaScript that, yeah, takes a string reversed, why not? And it gave me here the function and actually some test cases also. But I can as well say a GitHub pipeline to deploy an Azure function. And that didn't do so well. But what I prefer the most is, of course, if you need to call this within the function each time to generate some code. No, within Visual Studio Code, you have the Copilot, which is active. So that's also why you see the complete and text while I was typing certain things. Now here in this case, I just say, okay, generate a function that takes a string and return a list of all the words in the string. So if I now start typing def just function, I'm just going to start from scratch. Generate a function that takes a string and returns a string. Okay. That's not what it's supposed to do. It's always, again, during demos, it's not showing what I want. But I guess the idea concept is, because also it looks what's happened in your code before. That's why it's not.
What's the difference between Codex and GPT actually?
So the Codex is specifically to generate code in Python and all the languages, but in quite some different developing languages. Yeah, where GPT is really pure for language, but like I think GPT-4 can handle all of it now. Depends on what you're asking. Okay. That brings us, of course, to how do we actually bring this all together into a customer case. You might have already noticed the data from Kortrijk. So we're doing actually a project for the City Council of Kortrijk. I'll just give you a little bit of history of the project. So City of Kortrijk wants a conversational agent where they do not want to have a knowledge base, or like Microsoft has their Q&A service. We can have, okay, question, answer, multiple questions that can give specific answers. And it works quite well, but I didn't want to maintain that because you always need to update that. Okay, all our information is actually available on the website. Get it from there, get it done. So initial thoughts that we were doing, we looked at different kinds of tools. Azure Search was a good service at that time. And then in June last year, Microsoft announced on Azure Search, Azure Semantic Answering Service. Now at Answering Service, it extracts an answer based on the content in your index. So we made a Drupal module that syncs everything that's on their Drupal environment to the Azure environment. So when someone is asking a question, it can answer back. So how does that look like? We go to, because that's now online. So if I'm asked, for example, let's say alles aanvaarden. Hoeveel kost een vuilnis? So what's the price of a trash bag? It will give me the price and some highlights to it. This is not GPT or anything. This is purely some extractions out of the first or the best result that it actually has. But we did some logging on it to figure out how many of the queries that users are asking do we actually get an answer out of it, and that's only 20%. So that's not the best. So now GPT came. like, okay, let's try to do exactly the same. So we took all the data, we used the GPT models on it and asked the same questions and see what answers we are getting out of it. And that's now in the phase that we're doing validation on it to see how good it is and see if we want to actually bring this in production. But what I want to show now is in the backend what actually happens. So implementation A. But then with this implementation, we're not going to make use yet of Azure Search, which we are doing in Kortrijk. But what we're doing here, I'm just going to execute some things. So again, I'm getting my JSON data. Why is it? Okay, that's because it's data. Oh, sometimes codecs can also irritate you when it adds extra information that I don't want. So I just had my content. I normalize it. Initially, I would do the embeddings also. As I said, it would take half an hour, so I'm not going to do that right now. So I'm just going to read my pickle file, which contains all the data. Why are you giving me an error? Again, because I did not say data. So I have my values. Now, we do the search. Let's say this is saving embeddings is not possible in Azure Search. You have other tools like Pinecone who can actually handle that. It's another kind of database specifically built for vector search, but which is not available on the Azure platform. You have Redis, which is known for caching database, which has on Azure, you have Azure Redis Cache Enterprise, which has the vector search capabilities, which is quite expensive. If you run it in a container, it's quite cheap. So if you want to just try it out, take Redis as a container, Redis search in a container and run it on Azure. It will be cheaper than if you run it on as a service. But then, of course, you need to log and make sure everything runs well. So I have the same search service as I was showing in the past to get certain results. So I'm just going to run it. I have the same question. What's the price of a trash bag? I run the query. Now, instead of, in case I would use Redis search, I could use, I'm just running it now on top of this data set. And I get my top 4. Now, what I'm doing the next step is bringing all those content results back as one string. Say, okay, this is my top results. Now, that's the part about prompt engineering, which is actually becoming a new kind of job. How am I going to send things to these large language models? Where in this case, I'm giving some extra information already. I'm saying, okay, give me a short answer on next questions. And what I'm saying then, okay, the context is, and that's the data of my top 4 results that I received. And then I'm asking the question, what's the price of a trash bag? And then give me the answer. So that will look something like this, my prompt. So I have my extra information of how to reply on it. I have the context, and then I have Q&A. What's the price of a trash bag? Now, if we send this information to Azure OpenAI, get an answer, and then I can, let me just remove this because it shows better, print. And it gives me a nice answer. Now, I could as well say, instead of what's the price of a trash bag, what cost een PMD-vuilniszak? And it just gives me a short answer. Again, based on the information that it received. Now, of course, we might ask ourselves also, okay, we sent now certain queries. How much does that actually cost us? Now, we have the answer. Within the response that we're getting back, we also see what's the usage of the model. So if we query that, we see that the total tokens is 1,165. And now if we look at the pricing, depending on the model that we're using, so GPT, per 1,000 tokens. So we use the DaVinci. So that will have costed us like a little bit more than $2 for that on that single query. If I would have used the query, it would have been quite less, 10 times less. Which brings me to something that I forgot to show, is that within the embeddings, remember I generated embeddings based on DaVinci. Now, what if I do search through it, not with DaVinci anymore, but for example, query? Now that one will work, should work. It shows me the error. The error is retry error. Okay, that's not the error you want. Let me just see if it works with ADA. Okay, so with ADA, it gives me the example. So where DaVinci can handle 12,000 elements in its embeddings, ADA can only handle 1,024, so it can't do any similarity checks. So you need to make use of the same models that you did your embeddings on, that you also use for your similarity checks. So that's really something you need to keep in mind. Okay, back to the implementation. So we know how much it can approximately cost, how we can do search through it. Now, since there's not specifically a service yet that can make use of vector search, which has way better results than semantic search, we had in Kortrijk already pre-built, well, the solution was already online with semantic search. So we looked into that and see how we could implement that. So again, I'll just run a couple of, can you hide this? And now I'm having here quite a nice sentence. I'm not going to read it loud. You can read it yourself. But it's someone who's quite angry because he cannot sleep well because his neighbor is making too much noise. And let's see how GPT will reply on this. Now, what I need to tell you that is the content that we're using here is, of course, the 5,000 articles that of the pages of the website of City of Kortrijk, but also all the information that they used and tickets that were logged. So they have 1777, like you have for the Flemish region, you have 1700 to call when there's problems. They have 1777, and they make use of top desk system. So we extracted also all that information and added that into an index that could be used now in this case only for evaluation. So what we're doing here now is sending a query to the semantic search engine. And we're saying, okay, get us the top 5 and get me the specific question, or the complaint that was there, and already get me some results out of that. Now, if I run this, you will notice that I already get here 4 different top task tickets, because I think about these kinds of complaints, you will not find anything on the website. So it's good we added that information. Again, we see the kinds of tokens. We normalize this text. We have a lot of information now. And now in case, instead of using the GPT models, well, I also wanted to show GPT chat, which is GPT-35 Turbo. No, it's not the same, but you have GPT chat and you have GPT-35, well, 3.5 Turbo. Both of them use a different kind of prompting, where you need to start with I am start system, and then I am end, I am start, I am end, I'm start, and then it's ending by itself with a completion. So again, just as in the GPT-3 models, I'm saying here, you are a friendly employee of the city, only use the facts described below to answer on the question. And also remove any personal details out of the facts. Why am I saying that? Because in the index that we generated were just one-on-one copies of what was in the top task tickets, which means there's a lot of personal information, and we do not want that information to be given back to anyone. Is this foolproof? I'm not going to say so. As I said, this is still an evaluation, and before we were gonna go in production with this, we will remove that information firsthand before actually making it available to the public. And then I return the top results. I'm adding my question, and then the assistant needs to give the answer. So it's generating some text now. Well, sending the data. And now let's see what it answered to me. Well, if you read this message, notice also at the end, I am end, the end of the conversation. It's quite a nice answer. As if talking doesn't work, you can send in a complaint. Maybe he's not known that he's making so much noise. It's a very nice answer. Exactly, exactly. Now, what I could say, but that's also gentle because I said you need to be a friendly medewerker. Now, of course, let's imagine now this comes into via email and you want to automatically answer also. So again, prompt engineering, well, we can say in the back en antwoord, I can also say it in English, antwoord in de vorm van een e-mail. And it creates a nice email with nice hello, friendly greetings, and I can use it. Or what we can also say, I'm going to go back to GP3. Let me go change back to Azure to be sure. Which I want to show you also a bit the difference between the different models. So wie is Sammy Deprez uit België? Now I'm using ADA in this case. It's doesn't really give me an answer. Although its creativity is on 1. So if I change it to DaVinci 03. So I'm a Belgian guitarist and componist with an innovative guitar style. Yeah, that's not really what it's supposed to be. I have no idea how to play the guitar. But what if I update the prompt and say, als je niet zeker bent van het antwoord, zeg no answer. That answers no answer. If I would say something else, because it's of course you could say it's a trick. Wie is de koning van België? Oh, I did not try this, so I'm really wondering what it will respond. No answer. But it works. Sometimes you really need to play around with the prompt. No, I don't think so. Oh, that would be funny. Yeah. Look. Yeah. Okay, now I need to try again, and it's just to be sure. Wie is Sammy Deprez België? That's it. Okay, good one. Okay, I did not. Good one. All right. Now, how can, of course.
Email, would you tell? Imagine you put this in production. Would you actually put in the email like, yeah, this is generated by?
I personally would do. Yeah. So you can add some disclaimer. It's like, yeah, this is generated by AI. If you think it's not correct, please contact, just to be sure. Or just at least a disclaimer, which for emails, I think it's very tricky, because if you send an email back, people really respond it's correct, especially if it comes from a city council. So depending on the advice that you're giving. So for this kind of use cases, if you're generating emails, then I would rather say, okay, you build it into the system, and the people who are answering that question show an example of, okay, this could be the answer, just double check and click send, instead of looking up what needs to be done and write the email. That would still make the will make it way more performance than typing everything. So that really helps. Okay, so all of this we combined, of course, and some items where you saw this, for example, hoeveel kost een vuilniszak? Now, what we did is, of course, to refresh the page. We did the same thing here. Now, since it's sending it to OpenAI, it takes a little bit more time, but it will. This is also not production yet. We're looking into making it way more performance. So we generate an answer, and then, of course, the results linked to it. Notice, you see here, afvalcontainer and the jeugdlokaal. Okay, that still has to do something with trash. But then we have here thuiszorgtoelaag, that doesn't have anything to do anymore with trash. That's because semantic search will always give all the results back, but with scoring. But you can do some filtering on the scoring, which we did not do in this case. So it also shows some documents that are quite irrelevant. But that I actually also used to send to GPT. But he is so smart enough, he doesn't need to make use of this information. Now, since you have this, we created an API that just does all this information, does all these steps for us. Well, we can as well just implement it immediately in a bot. So what can I help you with? I can just say, goedenavond. Now there it is. Goedenavond. Goedendag, hoe kan ik u helpen? I did not change anything here. This is really purely sending the data to the API that we had created and responding back. Wat kost een PMD-vuilniszak? And it gives me an answer. Dankjewel. And that was not the purpose. As I said, we're still working on it. It's beste jawel, dank jawel. Yeah. So dank jawel. That works better. So spelling mistakes still need to be handled a little bit. As I said, we're still validating and see what we need to improve to get things in a better way. So what they're validating right now is the emails that are coming in via Topdesk and just saying in a simple way, just to refresh this page. So for example, there's a question here about jachtrechten for the city of Kortrijk. Then there's an answer that was given, but we also show, okay, this is the... Sorry. Okay, what OpenAI responded, and now it's the people of a city of Kortrijk that are just validating, okay, green, this is a good answer, red, it's totally not okay, or yellow, there's some work on it. So based on these responses, sorry? No, but based on this, we're looking how we can change the prompts to make it and give better answers. And also see, because now we're using the semantic search to get the top 4 to know what the context needs to be, if that's enough, or we will need to quicker switch to another solution.
Because in theory, in a more advanced setup, you could try to retrain the top layer to use this localized.
Yeah, but you can't just change the GPT models, eh? No, because you can't retrain that model on itself, or you need to ask Microsoft to do it on the whole thing. There's some item where you can add some extra information, but it's not something I have personally played with. It's also something I still need to look more into details. And that brings me to the end of my presentations. If there's any questions, shoot. If there's any complaints, shoot. I'll ask GPT if you can give an answer on it.
I'm not sure I understood correctly. The embeddings that just returns you the pages where your answer could be.
Yeah, exactly. So there's no Q&A system built in. This is actually the Q&A. You need to embed your documents to calculate the vectors, and then your question is also embedded, and based on that, those vector of numbers, is looked into all your documents and see which has the highest similarity. So each document then gets a scoring, and then it's the top 1, 2, 3, 4 that could have the actual answer. So you take those top 4 or top 3 that you will say to GPT, this is the context, use this. Now what you can do is also add, for example, an integer in front of it. So you do more, let me just open a new file. Let's say 1, this is about a document XYZ. Oh, 2, this is another document. 3, another document. Oh my, I can't type anymore. Another document, and so on. Let's say the top 4. You could say in your prompt, okay, these are the facts, and return also the number of the document that you've used. So that way you can also link back to the web page that you've actually used. And that's actually what Bing is doing. If you go to Bing Chat, let me go to my personal account. Let's also hear your temperature that you're setting here, creative, balance, or precise. So let me set in this price. What kost een vuilniszak? Zak in Kortrijk. That's also adding a little bit of more context, because if you just say what kost een vuilniszak, he might give you some answers. I remember showcasing this. I don't remember if it was creative or not, but it actually also showed me the links to Albert Heijn and the Deleuze with the price, how much it was costing there. Now, Bing Chat is being used quite often, so tempting to reconnect. Let's start over. What cost? Take. Okay, now it's doing it. Tick tock, tick tock. See, so Bing Chat cannot really give the correct answer. It gives on general information. And it says, okay, especially the links here, that's linking to the items that he thinks the information came from. So Ivago, Collect and Go, the Colruyt, where the information came from. So that system you can also implement within GPT. Some other things I tested out, because it was, for example, let's go back to GPT. Let's say answer, beantwoord in het Frans instead of in Dutch. Yeah, of course I will need to pick something else. Wie is de president van Frankrijk? Ja, that's. Hoe moet ik aardappelen koken? Hey, it's a French answer, which I find quite cool. So now this is just quite a common language. I tried it with a less common language, which is Swahili, for example, which is spoken by quite some people also, but not really where a lot of data sets exist of. And this one, of course, he needs to have some influence. Wat kan je vertellen over Nairobi bijvoorbeeld? It answers something in Swahili. If it's correct, I have no idea. I actually did a test. It was a bit different, my prompt, and asked in some Swahili-speaking people, like, is it correct what it was said? And I say, yeah, it's even quite good Swahili. So it's like, okay, cool. So there's so much possibilities. And now this is GPT-3 that I'm using. I have not tried it out, all these things with GPT-4, but I'm sure it's going to even be better. So if there's no more questions with that, I thank you for